In order to understand networking as a whole topic in cybersecurity, first we have to break it down into small topics, okay? And let's start off with the first one. What is networking? To teach this topic, I will be using my Cybersecurity Fundamentals textbook to guide me through it, okay? So the first topic that we're going to check is what's a network? So a network is a group of connected devices, okay? And how they work interconnectedly, okay? To make sure that everything is running smoothly. I'm going to read the definition. They communicate with each other through cables or Wi-Fi. They use unique IDs or addresses to locate each other. The addresses are internet protocols or media access control, which is MAC. Okay, another way to refer to it is MAC, and internet protocol is the IP. Okay, perfect. What are the different types of networks? Okay, we have local area network, LAN, okay, which is a network that spans a small area like office, buildings, okay, school, or your home. So that's LAN, LAN, local area network. The second one is wide area network or WAN. And this is a network that spans a large geographical area like a city, state, or country. There are 4 networking tools that you have to learn, okay? And I'm going to teach you how it helps me to remember them because they can. So, a router or router, depending on how you choose to pronounce it, is so a router connects the internet, firewall, and server to the rest of the network. A switch connects the network to devices like phones, tablets, workstations, and desktop. They only pass data to the intended destination. So that's the function of the switch, to pass data to the intended destination. Okay. A wireless access point can connect other devices behind a firewall, and a device connects to the network via a switch. So here are the 4 tools. We have a hub. What's a hub? A hub is a network device that broadcasts information to every device on the network, like a radio tower that sends signals to other radios, okay? A switch is a device that makes connections between specific devices on a network by sending and receiving data between them. The switch is more secure than a hub. A router is a device that connects multiple networks. A modem is a device that connects your router to the internet and brings internet access to the LAN. Remember, LAN is the local area network, okay? And all of this is on page 58. Okay, so that's for the network tools. The other thing that you have to learn when you're studying networking in cybersecurity is the TCP/IP model and the OSI model, okay? Which I'm going to read a little bit because it's very long, okay? And there are different layers in each model. Okay, so let's start off with the TCP slash, let me find it, sorry. Okay, so this is the TCP/IP model, okay, and this is on page 63. Why am I always covering it? Okay. And this model is made up of 2 types of protocols, okay? The IP, which is the Internet Protocol, and the TCP, which is the Transmission Control Protocol. What's the difference? The Transmission Control Protocol is an internet communication protocol that allows 2 devices to form a connection and stream data. The Internet Protocol, or IP, is a set of standards, okay, used for routing and addressing data packets as they travel between devices on a network. And that definition might sound sophisticated. It's basically going to tell you where the data packet is headed, where it's coming from and where it's going, where's the destination. So what is the TCP/IP model and why do we need it? So it's a framework used to visualize how data is organized and transmitted across a network. It helps network engineers and network security analysts design the data network, conceptualize processes on the network, and communicate where disruption or security threats occur. So that's the function of this model. We have layer 1, which is the network access layer or the data link layer, which deals with the creation of data packets and their transmission across the network. So this is where, let's say you're sending an email, this is where it would originate, okay? So the creation of the data packets. The second layer is the internet layer or the network layer, and this is responsible for ensuring the delivery to the destination host, which potentially resides on a different network. So this one is going to make sure that it arrives where it's supposed to arrive. The third layer is the transport layer, and it is responsible for delivering data between two systems or networks and includes protocols to control the flow of traffic across network. The next one is, and obviously in these layers, there are different protocols that you have to know. The fourth one is the application layer, and this is responsible for making network requests or responding to requests. And in this level also, there are different protocols that you have to familiarize yourself with. For example, the hypertext transfer protocol or the HTTP, which is in charge of the encryption, or HTTPS, Simple Mail Transfer Protocol, the SMTP, Secure Shell, SSH, Fire Transfer Protocol, FTP, and Domain Name System, the DNS, okay, are part of this layer. Perfect. So now let's move on with the OSI model. So the OSI model normally starts at layer 7, but I'm going to go vice versa, okay? So I'm going to start at layer 1, which is physical layer. And this corresponds to the physical hardware involved in network transmission. So this is where you'll find things like hubs, modems, cables, wiring, etc. And this is where the information travels across an Ethernet or and past a higher level of the OSI model. So this is where everything starts, and then it goes to the next level, which is the data link layer. And this organizes sending and receiving data packets within a single network. The data link is home to switches on the local network and network interface cards on the local devices, okay? The layer controls the following protocols. So network control protocol, high-level data link control, and synchronous data link control. I'm going a little bit fast. Let me slow down. The network layer, for example, oversees receiving the frames from the data link, so level 2, and delivers them to the extended destination. And for layer 4, this is the transport layer, and it's responsible for delivering data between devices. So this handles the speed of the data transfer, the flow of the transfer, and breaking the data packets down into smaller segments for easier transport, because typically if a data packet is too heavy, then it's broken down into different pieces, and that's how it's transported across the network. Layers 5 is the session layer. This layer describes when a connection is established between two devices, okay? So it opens the session to allow the devices to communicate with each other, and when the session is completed, it closes, okay? The next layer is the 6th layer, and this is the presentation layer. This layer involves data translation and encryption for the network. For example, an SSL encrypts data between web servers and browsers as part of websites with HTTPS, which means that these certificates, okay, for HTTPS, okay, they encrypt the information, okay? They're not going to protect you from anything. There's just an encryption that goes on in this layer. And the layer 7, okay, which is the application layer. This layer includes processes that directly involve the everyday user. So this is where you're interacting, okay, with the devices on the network. This layer includes all of the networking protocols that software applications use to connect a user to the internet, okay? And here you also have protocols like the HTTP or HTTPS, okay? The Simple Mail Transfer Protocol, Domain Name System, etc. Okay, so these are the two models that you have to familiarize yourself with. Awesome. So I hope this was helpful, and I'll see you on the next video. Bye.